This is the homework help video for Physics Homework 1.4. Remember, I will start you on each of the first 4 problems. The 5th one I'm going to have you try on your own. I won't solve any of these problems for you, so you're going to have to fly solo as far as finishing them off, but I will get you started on the first 4. The first one here, we've got Luke and Leia holding onto a rope at a 30-degree angle with the vertical. Their mass is 1,450 newtons, and we're looking for the tension in the rope. How tight or how taut is that rope? The big thing here is to remember that the vertical component of the tension, the piece that goes right here in our little triangle, is 1,450 newtons, because that's how much Luke and Leia weigh. So when we make our triangle, we already know one angle. We know that this component of the triangle, whoops, sorry about that. Let me erase that piece. We know that this component of the triangle is 1,450 newtons, and now all we have to do is use the cosine identity to solve for t. In the next one here, we've got the 2 trees. Little Susie, or Sarah, or whatever her name is hanging a birdhouse from it. We know that the birdhouse weighs 24 newtons. We know that the tension in the rope is 480 newtons. So I think you're best served actually by drawing another triangle that's similar to half of the outline triangle that we have here. This is simply half of that triangle. We're looking here for theta. We know that this is 480 newtons, and that this, and be careful here, is 12 newtons, because half the line carries half the weight of the birdhouse. From there we can find theta. You'll draw yet another triangle using theta, and using the fact that you know this distance is 2.0 meters, or half of the distance between the trees, to find x, because we're really looking here for the distance that the line sags. Moving on to the next one, this is very, very similar to number 1. The big thing here is to remember that the vertical component of the tension is the same thing as the weight of the object that we're lifting. So we've got our triangle here. We know that the vertical component is going to be 10,500 newtons, and we know that we've got a 10-degree angle, so we've just got to use that cosine identity again. Moving on, and this is the last one I'll help you with again. We've got Gambini. This is really similar to number 2, except we're kind of working in a different direction. We've got a 30-meter tightrope, a 750 newton weight in the middle of it, or Gambini in the middle of it, and we're pushing it down 15 centimeters in the center. Remember to convert your units here. Be careful with that. But we're simply going to want to draw another triangle. So we're going to get our triangle drawn here with a 15 centimeter sag, or 0.15 meters. Be very careful about that. And then a 15 meter half of an edge. From that, we should be able to find theta. This should look really similar to the last problem. Once we get theta, we can use that to solve for the tension in the rope, because we know theta now. We know that this component of our tension is going to be half of Gambini's weight, because half the rope carries half the weight, so that should be 375 newtons, and then we should be able to solve for x. Here we'll use the sine identity. Number 5 is going to be really, really similar to number 4 here, so I'm not going to help you with that one. I'm going to ask you to go ahead and try that one on your own. I hope this helps. Good luck on it. If you have questions, please come with them on Monday. I fully expect that you'll have questions. I don't expect this to be easy, and I want you to have to do a little critical thinking and problem solving with it. So I'll see you on Monday. Have a great Labor Day weekend.